Okay, solving for the inverse of a function. So how do we solve for the inverse of a linear function, for example? So all you have to do is to switch the position of your x and your y. So our example here, we have y is equal to x plus 1. Y is equal to 2x plus 1. So as I have said, switch the position of your x and y. So we have x is equal to 2y plus 1. Then solve for y. So we now have by additive inverse, we have again by additive inverse. So this is plus 1 additive inverse. So we have negative 1 minus 1. Since we add negative 1 in the other side, we also add negative 1 in this side. So negative 1 plus x is equal to 2y plus 1 minus 1. So the result is we have x minus 1 is equal to 2y. Then by multiplicative inverse, so we get x minus 1 is equal to 2y. By multiplicative inverse, we have, so multiplicative inverse of 2 is 1/2, or we divide both sides by 2, or we multiply all of the sides by 1/2, then we will get x minus 1 is equal to y, then this is over 2. So x minus 1 over 2 is equal to y. Or finally, we have our final answer is, so y inverse is equal to x minus 1 all over 2. So this is our final answer. So the graph, of course, we can make use of GeoGebra and graphing. So the first equation here, y is equal to 2x plus 1, and the inverse is this one, y to the power of y inverse is equal to x minus 1 all over 2. Okay, another example. Let's say we have y is equal to x plus 1 all over x minus 2. So we have y is equal to x plus 1 all over x plus 1 all over x minus 2. So again, switch the position of your x and your y. So we have x is equal to y plus 1 all over y minus 2. Then solve for y. So we continue. So if we have x is equal to y plus 1, plus 1 over y minus 2. Is it correct? We're correct. So to solve for y, we have by using the multiplicative inverse. So let's multiply this with y minus 2. We arrive at, what's the result? Okay, the result is x times y minus 2 is equal to y plus 1. Then using the distributive property, we have xy minus 2x is equal to y plus 1. Okay, let us continue. So by additive inverse, if we have xy minus 2x plus rather equal to how do we erase this? No, this is equal to y plus 1. Y plus 1. So this is equal to y plus 1. Then by additive inverse, we have xy minus y is equal to 2y plus 1. Then we factor, so we arrive at y is times x minus 1 is equal to 2y plus 1. Let us continue. So we have already y times x minus 1 is equal to 2y plus 1. 2y plus 1. Then by multiplicative inverse, we have our final answer. So we have y is equal to, where are we? We don't factor yet. This is not 2y, but rather this is 2x. So here 2x. Sorry, this is 2x. So this is 2x. Let's continue. So again, this is 2x. So we have 2x plus 1 all over x minus 1, and this is inverse. So the inverse is 2x plus 1 all over x minus 1. Let's review. So our given, we have y is equal to x plus 1 all over x minus 1. Then by switching the position of your x and y, we have x is equal to y plus 1 all over y minus 2. Then by multiplicative inverse, so we multiply both sides by y minus 2, so we arrive at x times y minus 2 is equal to y plus 1. Then we have, by distributive property, x y minus 2x is equal to y plus 1. Then we have times x minus 1 by factoring, which is equal to 2x plus 1. So our inverse is equal to 2x plus 1 all over x minus 1. Let us see if we have the same answer. So our inverse, we have 2x plus 1 all over x minus 1. So the graph here, the original graph is y is equal to 2x. Y is equal to 2x plus 1. This is the original. And the inverse, the curve is brown. So we have y inverse is equal to 2x plus 1 all over x minus 1.